In this lesson, we're going to be solving radical equations that involve some problem solving, and for the most part, all of the problems that we're going to be solving have to do with Pythagorean's theorem. And I know you've seen Pythagorean's theorem before, but let's just go over it, just for the sake of those that may not have seen it. Okay, so the very first thing we do in Pythagorean's theorem is we identify the hypotenuse and label it C. Okay, so the hypotenuse is always, if I draw and split my right angle and draw an arrow, it points to my hypotenuse, and I'm going to label it C. The two other sides of the triangle, I can label them A and B. It doesn't matter if I label the left one or the bottom one A or the bottom one or the left one B. They can be mixed up in any order. So what did Pythagoras discover many centuries ago? He discovered that if you take the legs, these are called legs and legs, and this guy right here is called the hypotenuse. Hypotenuse, I always misspell that. If you take the legs of a right triangle and square them and then add them, that equals the hypotenuse squared. So when we work these problems, we're going to follow 3 steps. Step number 1 is to identify the hypotenuse. So we're always going to draw an arrow through my right angle, and it's going to point through to the hypotenuse. I'm always going to label that C, and then I'm going to label in any order the other 2 sides. I'm going to label that A and B, and then I'm going to set up the equation, Pythagorean equation, a squared plus b squared equals c squared, and I'm going to solve it. So let's go ahead, and in all of these examples, we are going to solve for the unknown side. So we're going to have to label that side with one of our A, B, or C letters. So here we go. Step number 1, identify the hypotenuse. So I draw my arrow, that's my hypotenuse, and label it C. So my hypotenuse is my unknown side. The other 2 sides I'm going to label A and B in any order. So A is 12 and B is 16. And now step number 3, I'm going to set up my Pythagorean equation. A squared plus b squared equals c squared. I know A is 12. 12 squared plus 16 squared equals c squared. And this is where your perfect squares, memorizing those, come in really handy. So when I square 12, I get 144. When I square 16, I get 256. C squared. So when I add 144 and 256, I get 400. Well, how do I figure this out? I can take the square root of both sides. So I'll move over here. The square root of 400 equals the square root of c squared, and we can't forget our plus or minus in front of that, because there's 2 numbers such that when I square them, I get 400. So I know for distances, we only really use the positive one. We can't have a negative side to our triangle. So when I factor 400, I know from my knowledge of perfect squares that 400 is a perfect square, and it factors into 20 times 20. I'm going to take my positive c value and not my negative, and I'm going to pull out a group of 20s out, and I get c equals 20. And that's how you use Pythagorean's theorem to solve for the unknown side of a triangle. So in my next example, step number 1, let's go ahead and identify my hypotenuse. Draw your arrow to it. This is going to be C. This side I'll label A and this side B. So when I set up A squared plus B squared equals C squared, A is 6, 6 squared. I don't know what b is, so that's going to be my unknown side. And then I'm going to get 10 squared because c is 10. So I end up with 36 plus b squared equals 100. When I subtract 36 from both sides, because I need to isolate my squared term, I get 64. And remember, I am going to take the square root of both sides, and I can't forget my plus or minus. I'm going to move up here. So the square root of something that's squared is just itself. And since distances on a triangle are always positive, I'm going to take the positive square root of 64. And I know 64 is a perfect square. It's 8 times 8. So I get a positive 8 for b. Okay, and then I'm going to do this problem here. And it's like problems 3 and 8 on your worksheet. So step number 1 is identify the hypotenuse. And there it is. This is going to be my C. Label the other two sides as A and B. And then step number 3 is to set up Pythagorean's equation to solve. So I don't know what A is, but I do know B is radical 7. And I know C is 8. And when I square a square root, it takes the square root symbol away. 8 squared is 64. So now I end up, when I subtract that 7, I end up with a squared equals 57. All right, so let's see if 57 can be reduced. When we take that square root, I'm going to take the square root of both sides, and I get a plus or minus 57, and I know that when I take the square root of something squared, the square root and the square cancels out. I'm going to work with the positive radical 57 because this is a distance. Well, I know that 3 goes into 57. It goes in there 19 times. And since 3 and 19 are prime, I have no groups of 2. So I believe A is just going to equal the square root of 57, and we're done. Last example here. This example is this is not the last one. I have one more after this. Step number 1, I am going to identify my hypotenuse. There it is, and label it C. Step number 2, label the other two sides A and B. Step number 3, set up my Pythagorean equation. So I know A is 3, so 3 squared. I am missing B. I don't know what to put in for B, so that is my unknown side. And then I have 3 radical 37 for C. So here I have to square my 3 to get 9 plus B squared. And now when I square this, I am going to write it twice. And remember, I have to multiply the numbers on the outside, so I get 9. And I'm not multiplying, I'm going to multiply the numbers under the radicals, but I'm not actually going to multiply them. I'm going to write them like this. And this produces a group of 2 37s. And now I can pull one of them out. B squared equals, what is 9 times 37? Well, we will figure that out. We will say 9 times 30 is 270, right? We're going to multiply place values. 9 times 30 is 270. 9 times 7 is 63. So I get 333. Well, when I subtract 9 from both sides, I get B squared equals 324. Okay, this is where your perfect squares come into play. That should ring a bell, 324. I get B, and this is a positive number again. B equals 324 is 18 times 18, so I end up with B equals 18 as my final answer. And this is going to be the last example we do. This is just like problem number 10, very similar. Step number 1, identify your hypotenuse and label it C. Step number 2, label the other sides A and B. Step number 3, set up our Pythagorean equation. So I don't have anything to plug into A. B is radical 2, so I have to square that. And C is radical 5, so I have to square that. So I end up with A squared plus, remember when I square a square root, the square root goes away. When I square a square root, the square root goes away. So now when I subtract 2 from both sides, I get 3. So now I have to take the square root of A squared and the square root of 3, and I can't forget the plus or minus. I almost wrote A squared. The square root takes away the squared, equals, and I know this is a distance, so I'm going to get rid of the negative version. And the square root of 3 does not simplify, so I am done. So go ahead and take your worksheet out, and you can go back and stop these problems at any step that you want to. But I have labeled on here which problems each one of these examples is similar to.